Hello all. In this session, we will be discussing a problem on isometric view. In the previous two videos, we have discussed the construction of isometric projection. So in isometric projection, we will be using an isometric scale to finding out the actual dimension which an observer will be feeling while he is looking at the solid. Whereas in an isometric view, for simplicity, we will be using the actual dimension. Such views we call as isometric view. In this question, you are asked to draw the isometric view of a pentagonal pyramid whose sides are 30 mm and the axis 70 mm and it is standing vertically on its base. So as I discussed in the earlier videos, the rule for drawing isometric view or projection is all horizontal edges should be drawn at an angle of 30 degrees to the base and all vertical edges should be drawn vertically. So this will be applicable if the solid is having a side which is square or a rectangle. So if any other shape is there in the question, you have to inscribe that solid or inscribe that view within the smallest possible square or rectangle. Then we'll go with the construction of the isometric view or projection of that square or rectangle, and then we will transfer the points to that. So let's see the construction of the pentagonal pyramid. First, we'll draw the orthographic view of the pentagonal pyramid and label it as A, B, C, D, and E. Hope you know the construction. Then we will inscribe this inside the smallest possible rectangle or square. So you draw the rectangle touching all the corners, and I name it as 1, 2, 3, and 4. So this has to be drawn using actual dimensions since the question is on isometric view. If the question was isometric projection, you should draw the iso length corresponding to 30 mm for drawing this pentagon. Now for drawing the isometric view, first you draw a baseline and I'm going to pivot a point. So this pyramid is resting on its base on the ground. That means the pentagonal face, you assume that pentagonal face as a pentagonal lamina. So that lamina is horizontal. So there are no vertical edges for that lamina. So what we'll do is that we'll consider that it's a sheet of paper. So it is lying on the ground. So 1, 2, 3, 4 is a sheet of paper lying on the ground. So there is no vertical edge. So all are horizontal edges. So the rule is all horizontal edges should be drawn as lines inclined at 30 degrees to the base. Now you can pivot any point, either 2 or 3. It's up to you. So I am pivoting the point 2. Then I am drawing the line representing 2, 3 at an angle of 30 degrees to the base. And similarly, I'll draw 2, 1 at an angle of 30 degrees to the base. And I'll immediately label them. Then I'll draw another line representing 1, 4, which is inclined at an angle of 30 degrees to the base. So the easiest method is to translate the line 2, 3 using a set square and a scale, or you can use a roller for relocating this line. And then you close the point. So that is the point 4. So this is a skeleton. This should be drawn as a very thin line because this is not part of the solid. This is actually meant for construction purpose. Now the next step is to locate the points A, B, C, and A, B, C, D, and E. So they will be written as capital letters in the isometric view. So using a compass, you measure the distance from 2 to this point A, and you plot that point in this isometric view. So using a compass, you plot the point A. Similarly, from 3, you locate the point B. From 3, using a compass, you measure the distance C3. And from 3, using that compass, you mark that point on the line 3, 4. Then you measure 4D, mark the point D. Then you measure 1E, mark the point E. So this gives you all the points. Now you have to join all these points using continuous lines or dotted lines. So there comes the concept of visibility. So when you're looking at the solid, you have to identify which are the corners or which are the sides which are visible. So they have to be joined using continuous lines, and the invisible edges should be drawn as dotted lines. So we'll join them. So here I am joining all the points, joining all the corners. So this is an invisible edge. So I've joined A, B, C, D, and E, And if you look at the solid, you can see that CD will be behind and it won't be visible. So I have made CD as a dotted line. Now for drawing the axis, the axis will be vertical. So this has to be drawn as a vertical line itself. So you have to find out the geometrical center uh, of this lamina. So you can draw two diagonals and the meeting point will be the center. So from the center you can draw the axis. So axis is drawn as a chain line. So line dot, line dot, line dot. So you can draw the axis at a height of 70 mm from the middle of this lamina. Now you join the points A, B, C, D and E with the apex O. So I am joining them and ensure that all visibility checks are being done. So this edge will be invisible. Similarly, this base will also be invisible. So this is the isometric view corresponding to a pentagonal pyramid. So this visibility, you have to be very, very careful. So all the visibility should be drawn as continuous lines and invisible edges should be drawn as dotted lines. Then you can go with the dimensioning. You can spread out the dimensions. So the sides you can show here as 30 mm and the axis from here you can project from these 2 points, you can project and write 70 mm, and on the right top you write scale is 1:1.